Hi, I'm Brian Grant. I was part of the original team that created Kubernetes. Among many other things, I created kubectl apply and customize. And I'm going to be showing you something we've been working on in the KEP project that I'm pretty excited about. This is a pretty typical Kubernetes graphical user interface. We get some step-by-step guidance, recommended defaults. It's really helpful for getting started, but it's not recommended for managing production environments. Why not? First, it's manual. I'm starting from scratch. I could follow internal documentation, but that can be error-prone. And what if I need to make 10 similar copies of it? That would be tedious. Second, when I click create or deploy, it immediately changes the live state. Or what if I click delete instead and destroyed a production resource? There's no change control, no review and approval. Third, let's say I did make a mistake or something else went wrong. There's no undo natively in Kubernetes for most resource types. Think about other software content authoring products. Documents, spreadsheets, presentations, image and video editing, website creation, and so on. They all have WYSIWYG editing, versioning undo, copying and sharing, export and import, and so on. Now I can get some of these capabilities by storing configuration files and version control and building deployment pipelines with safeguards I need. And this is exactly what users do. They transition other tools in order to automate, collaborate, perform frequent tasks, make risky changes, and so on. This UI even tells me to do that. Kubernetes deployments are defined declaratively using YAML files. The best practice is to store these files in version control so you can track your changes to your deployment configuration over time. The Kubernetes resource model was designed so that declarative configuration uses the same format and schema as what the Kubernetes API accepts directly. So configuration can be represented using many different syntaxes, but they all translate down to that same basic form. One way you can represent them is using the basic YAML syntax, but usually you need to provision a set of resources together to do anything interesting in Kubernetes. Usually multiple resources are required. For example, an application requires at least a service, and deployment usually, or deployment in a config map. This is a common cluster admin or platform team example where they need to provision namespaces and associate policy resources like roles and role bindings, resource quota, network policy, and so on for the applications that need to run in their cluster. This is an example role binding, for instance. In order to create multiple variants of those resources, some kind of customization is required. So creating multiple variants is the core use case that we created customized for. This is an example of a set of patches to change the group in the role binding and the namespace name, for example. But you could use other tools. You could write a set of templates using Helm and parameterize every attribute, and then create a values.yaml file for every variant that we wanted to create. Or you could create or find an operator to stamp out the set of resources that are needed for each namespace, and then configure the operator for each variant. But wouldn't it be cool if you could do all that through a graphical user interface? I'm going to show an example of what that could look like. So I'm going to create a blueprint for creating a simple namespace and a role binding. I'm just going to call the blueprint simple namespace. And I'm going to add the set of resources that we want provisioned in each variant that we stamp out. So we're going to add a namespace, not a lot to be configured there, and we're going to add a role binding. We'll call that app admin because we're going to bind it to a cluster role called app admin. And we're going to bind that to a group with the name of a form decided by the platform team. So by convention, it will be namespace.admin will be the name of the group that we bind to. All right, then we just need to specify the instructions for how to create each variant. So to do that, we'll add a KRM function. These are the same functions that implement, same types of functions that implement transforms in Kustomize. And here we're going to use them for effectively the same purpose. So I'm going to change the name of the namespace to match the name of the clone of the blueprint that we are creating. Now we also need to customize the name of the group that's bound to in the role binding. So to do that, we will use the customize replacement transformer. And we just need to specify where the value should come from. And again, we use the name of the package where to put the value in the role binding. There it is. We just want to replace a part of the string, so we'll do that. We're just using an example as a placeholder for the name of the namespace everywhere here. Okay, and that should basically be it. So we will save this blueprint and propose this as a new blueprint. Now another member of the platform team could review it by inspecting the details of the blueprint here. So we see what the role binding looks like, that the group follows the platform team's convention. For example, we actually noticed a mistake. We can go back and edit it and say, hey, you actually need to add apply the replacement transformer function to make that run, and we can fix that and repropose it. And once it looks good, then someone can approve it. Okay, now once this is approved, it can be used to deploy new instances from that. So we could deploy right from here if someone was looking to see if that blueprint was appropriate, but we could also start from the set of variants that have already been deployed. And here we don't have any yet, but we will add a deployment using the blueprint that we just created. So we'll call it a namespace for a backend, and that is basically all we need to specify. Now we can confirm that the changes are made as expected. So the name of the namespace is indeed backend1, and the role binding is in the namespace backend1 and has this namespace name substituted into the group that's bound to as expected. So we'll go ahead and propose that change. And again, someone could review it to make sure that it matches everything they expect and then approve it. Now, that doesn't seem like it saved much work for just creating one, but creating a second one is just as easy. I just select the blueprint and propose and approve the change. And now we did all that through the graphical user interface. These things can be deployed under the hood using GitOps. So we'll just log into the Kubernetes dashboard here, and we see they're already in the cluster. And that's because they got written to Git and were deployed via GitOps. The blueprint we created was also written into Git. So all the versions that we create and modify are all stored in Git here. So like the UI we showed in the beginning, we can build the kind of UI capabilities that we're used to in terms of step-by-step guidance, recommended defaults, validation, and so on. But we can also get features that we've come to expect through from GitOps, like review and approval and versioning and undo, but access all of those through a friendly graphical user interface. So anyway, I'm excited about this. I think it can potentially transform how people manage configuration and deploy to Kubernetes. If you're interested, take a look at kep.dev. Thanks.